Hi science teachers, welcome to Real Science Challenge. I'm Kent Louie, teaching science and broadcasting from beautiful Vancouver, Canada. And to all of you, thanks for doing an awesome job teaching your students. Now today is an episode of EdLab where I share something I want to try with my students. For assessment this school year, I want to try something I call the full term science question. So basically, I'm going to ask an open-ended science question at the beginning of the term and then ask the same question at the end of term to see how much more detail and skill has been acquired over the term. And I'm going to mark the students' answers for growth between the first time I asked the question compared to the second time I asked the question. Now in a minute, I'll go over a question I've used in my class. If you've done something like this before, or I'm trying this with your class, please let me know how it went in the comment section below. And for all handouts, please go to realsciencechallenge.com EP10 and subscribe to our YouTube channel. So here's the story. When I taught summer school a month ago, I wanted to give my physics students a final exam that didn't have any calculations, but still required them to apply their conceptual knowledge into their answers. I didn't want students to just regurgitate knowledge or just take random numbers and plug them into formulas. I wanted students to find connections and applications between what they were learning in class and the real world. And I wanted them to think like a scientist. So I experimented with a physics final exam. And you know, physics finals usually have a lot of math. Well, mine actually had no calculations, just a bunch of written questions. And this is the exam here. As you can see, it's just all written work. You know, I'm quite proud of this final exam, even though it's my first time trying it. And one question I gave was this: how is, or what career do you want in the future? How is physics applicable to your future career? Provide two specific examples and explain your examples of how physics is present in your future career. And here, to read one of the weakest responses I received, is my lovely assistant. Lovely assistant?
Yep. I'm interested in becoming an architect in the future. Their career revolves around visiting the construction site and working in an office. On site, an architect is aware of the conditions the building will be in. They can then recommend materials that will perform well, such as reflective material, to keep their building cool. To draft a building to scale, an architect will need to use trigonometric formulas to find values of the building.
Thank you, lovely assistant.
You're welcome. Anytime.
Now, the reason why this is one of the weakest responses I received is because of the lack of detail and explanation in their answers. You know, this student is interested in becoming an architect, and let's think about what architects have to deal with. You know, they got to think about putting up a building. They got to make sure the building stands up. They got to make sure it has the right materials to hold that building up. So there's a lot of forces and structures that go into building buildings. But this student said that, you know, architects just do nice fancy drawings. They draft things. They might use trigonometry, which is something, you know, I give credit for. This student did pull in the idea of trigonometric functions, which we cover in physics class, but they didn't talk about forces, which is a huge thing in physics, and it's a huge thing in architecture. So these details, or these lack of details, is the reason why this student only got like a 2 out of 4 on this response. And here again, to read one of the strongest responses I received, is my lovely assistant.
I want to be an artist in the future. When sketching, you need to know how much pen pressure you use to produce a gradient of tones in your art. However, if you press too hard, you'll rip the paper. Your pencil is exerting a force to the paper, and the paper is grinding back at the pencil with an equal yet opposite force. Newton's third law creates the opportunity here to create values in your art using the same pencil.
Thank you, lovely assistant.
You're welcome. Anytime.
Now, the reason why this is one of the best responses I received is because it just brought to light some things I never would have thought of. And it did with such great detail. It says, I want to be an artist in the future. And this student even went on to say, well, artists have to think about pen pressure and forces and gradients and just the level of detail and the thought that went into this answer. I would have never thought of these applications. The thing I like most about this question is how it showed me how a lot of students can't form or aren't actively forming connections between what they're learning in science class and the real world. And perhaps as a science teacher, I need to make an even more focused effort on making these connections apparent to my students. And perhaps my students also need to actively look for these connections too. It needs to be top of mind for them. So this time around, I'm hoping that throughout the term, students will become more aware of how science can be applied to everyday things and not just learn this stuff in isolation. But as a teacher, I also hope to be more purposeful as to making these connections for my students throughout the term. Now, I don't know how it will actually turn out, but that's the reality of teaching. A lot of things, a lot of outcomes, we don't have a defined outcome yet or defined answers yet. And that's okay. It's all about progress and not perfection. And that's it for this episode. Please remember to subscribe to our YouTube channel. Thanks for watching, and remember, the science every day, everywhere. Remember, the science everywhere, every day.